This next session, we're going to maybe feel like we're going to shift gears a little bit to talk about the issue of math pathways. And why are we doing that? Well, one of the things that's almost as abundantly clear as a commitment to co-requisite remediation is that if it's going to happen in mathematics and be done so effectively, we're learning more and more that it's not about, it's that, you've heard this point already, that the singular path, a march through, through intermediate algebra, elementary algebra, intermediate algebra, then college algebra, is not the solution, and that more and more we're recognizing that alternative pathways through mathematics make a lot more sense, but not just for developmental education purposes, for a much broader reason, because of what is an appropriate role for mathematics in an undergraduate education. And so we've jumped into a partnership with the Dana Center. So Uri Treisman, who you're going to hear from a little bit later, and Amy Getz, who's with us today, in a partnership working with 6 states plus the Houston metropolitan area to work through not only how do we define alternative pathways in mathematics for the purposes of developmental education, but actually for all of undergraduate education, creating appropriate math courses aligned to courses of study or programs of study that make sense for those programs of study that are fully transferable and enable students to get the math skills they need to be successful in their program. And so we're joined by representatives from 3 of the states we're working with. We have Rebecca Watts from the Ohio Board of Regents. We have Dean Allison from the University of Northern Colorado working on the Colorado project, and Mary Shepard from Northwest Missouri State in Missouri, where they are also part of this project. And we're so excited to have them with us to talk a little bit about their experience with our Math Pathways work and why it is very important and central to their efforts around not only just developmental education, but college completion, generally speaking. So what I'm going to do, first of all, is just start off with Amy at the Dana Center. Many of you, I'm sure, have heard Uri, and you're going to hear him today if you haven't. They have really been the voice on these questions and issues, and they have really raised the conversation about why and how we can be developing some new options for students in mathematics. And in doing so, they have become really an important leader in the college completion movement, as well as just generally speaking, undergraduate education in this country. So Amy is working hard with us, and I'd love to have her give the pitch and why Dana Center thinks this is such an important issue.
Thank you, Bruce. So Stan and Tristan have already presented some of the really important ideas about math pathways, but I just want to reiterate a couple of points. For those of us who teach and love mathematics, it is an absolute tragedy that math is the obstacle to students' completion. We want students to be able to engage with mathematics and learn mathematics that's of value to them. So we think it's really important that we find ways to improve those success rates, but we also do not want mathematics just to be a hoop for students to jump through on their way to completion. And so this concept of math pathways is really important because you're also here talking about co-requisites, which is a way to accelerate student success. But if we are only accelerating students to successfully complete irrelevant content, that has not really served a purpose. And that's not what we as math educators want to accomplish. So what our goal is to ensure that every student, whether they're coming in at the developmental or college-ready level, has the opportunity to be successful and learn mathematics content that will be relevant and valuable to their lives. And the college algebra pre-calculus track, I'm not going to agree with Stan that it's equivalent to Latin. But even the Mathematical Association of America in 2004 said that those courses are not appropriate for general education, and they are not appropriate as terminal courses. That those courses were designed to serve students who are continuing into higher level math courses. So if the Mathematical Association of America said that 11 years ago, why is college algebra still the most commonly taken math courses in community colleges and four-year institutions in this country? That's the question we have to ask ourselves. So that's the concept behind finding alternative pathways that are more appropriate for many students. Stan showed the slide earlier showing quantitative reasoning and statistics are certainly two of those pathways that many people are exploring. Technical math, you're going to hear about about that from Ivy Tech later. Sometimes we hear that there needs to be a business track. So the idea is that we need a small number of clearly defined, articulated pathways. The second piece of this, though, that is just now becoming apparent is that actually that calculus pre-calc track is not leading to calculus for most students. A new study from the MAA is showing that most students who successfully complete calculus actually took it in high school. So now we're stepping back even further, and we're saying, you know, we need to look at all of our math programs and ask the question, what's the evidence of whether they are successfully preparing students for what they're designed to do? We want to raise that bar so that we are proving to ourselves and our constituents that we are providing the best support possible for students to succeed. So the Dana Center started this work in Texas with the new Mathways project. And then as we started to ask how could we support this work in other states, we developed this concept of math task forces. Started first with Georgia, then Ohio, and now with this work with the Complete College America in the other states Bruce mentioned. So the concept here is bringing together faculty leaders from 2- and 4-year institutions, along with representatives of the policy agencies, to jointly go through a structured problem-solving process to understand the context within their state, identify the real issues locally, and create a set of recommendations about how to implement math pathways in their state. It's really important to note this is a faculty-driven process. Math faculty need to be in the lead on this, but they also need support from policy and administration. And now the 6 states that Bruce mentioned and the Houston area have all drafted their recommendations. Some of the reports are actually finalized. All the reports will be available publicly in September. And the task forces are now working on how they look at implementing and creating state action plans for that.
Thanks, Amy. And so, like I said, 3 of the states that are participating in the initiative are here with us today. I'm going to start with Rebecca first and talk about, you know, you jumped in actually early. We kind of swept you into an initiative when you were already well down the road and you worked with the Dana Center. So I'd love to maybe both Amy and Rebecca both to comment on this and sort of what was the ground laying that actually got Ohio over a year ago to take on this effort of committing itself to developing these pathways for Ohio students?
So the real catalyst for this work was something that actually Stan referenced earlier, which was establishing a statewide remediation-free cut score. So across all of our public 2- and 4-year institutions, what does it mean to be remediation-free? What does it mean to be college-ready? And we did that for mathematics and English. And to a degree, we did that for science. But then the discussion started among statewide mathematics faculty, okay, college ready, but for what gateway course? And then there was this broad-based recognition. We're still pushing everyone through college algebra as a precursor to calculus as our default gateway course, and the realization that that's not the correct gateway, in fact, for all students, for all majors, regardless of their preparation and their ability to be ready to move on. So this work started by saying we need to have a broader array of gateway courses available for students in all majors, STEM and non-STEM, so that we're getting students what they need. And so I guess the real catalyst was, what does it mean to be college ready, and college ready for what? Because it absolutely depends on what the student's goals and dreams are.
So Amy, tell me about how you guys that came together. What was sort of I mean, you had already done some work in Georgia, right, doing similar things. And what do you think made Ohio sort of a prime candidate to take on this work from your point of view?
So one of the things that attracted us about working with Ohio was the commitment from key stakeholders and we see this as really critical, needing to have the policy side being willing to come to the table, having a flagship university leadership, and also the collaboration between community colleges and the 4 years. So we're very suspect of places where there's only one of those three that wants to do work, because we think that this really does take systemic articulation and coordination.
Great. So Dean, now Colorado, as you've already heard, has been prominently featured today and will be a little bit later on. There's a lot of things happening in Colorado around college completion. New policies around remedial education. You already had a really robust transfer system in place that you would suggest, at face value, might mean that some of these issues had already been resolved in Colorado. But nevertheless, there was a challenge. So talk more about why Colorado really needed to take this next step.
Well, so as Bruce says, in many ways we have pathways developed in the state. Almost all the institutions have an introductory stats course. They have some sort of a quantitative reasoning, math for liberal arts, and of course we all have our college algebra and our calc path. But one thing that we discovered well, first of all, the task force came together just last September. It's got about 13 math faculty from the full range of institutions, flagship research universities, for all the 4 years, 2 years. And when we started looking at some of our own data, one of the things that surprised us was how many institutions were still relying on college algebra as the default. Some institutions did not have that practice, some did. The answers to why, we still don't fully understand. It's not so simple as saying it's the characteristic of the university. That is, it's not just their mission. So I think the other big problem that stood out for a lot of us is we do have very good guaranteed transfer in Colorado. Any gateway math course that is taken at any public institution, 4-year or 2-year, is guaranteed to transfer to any other institution. However, that may not be an effective transfer. That is, they may take college algebra at one institution. They may transfer into our institution in criminal justice. Our criminal justice is quite firm. You have to have an introductory stats. They want to prepare people for the statistics courses that they take in criminal justice at the junior level. So it's a problem of effective transferability that has shown up to be a problem in Colorado.
So, the community colleges actually went through a process where they designed some very specific pathways to get students through remedial education. They have a pathway for college algebra preparation and then a quantitative literacy and quantitative reasoning pathway. But if you look at the data, and you actually found that despite the fact that these pathways had been defined, still the vast majority of students were going through college algebra. Right. So talk a bit about that disconnect, even though, like you said, there were actually pathways available to students at the 4-year institutions. So.
Well, so I sort of referenced this a moment ago. When we collected the data, we had about 6 4-year. I'm not sure if this is going to answer your question, but I'll give you just a little bit of data. We had about half of our 4 years that had their students pretty widely distributed among introductory stats, a math for liberal arts path, and college algebra. And then we had about the other half of our 4 years where the vast majority, 60, even up to 80% of their students were all being funneled into college algebra. When we looked at the community colleges, they all fit that second pattern. Almost all of them have 60 to 80% of their students going into college algebra. I don't think we fully understand all of the reasons why. A lot of it has to do with advising. We have some very small rural community colleges that actually just have trouble finding enough instructors that are qualified to teach introductory stats. They can find plenty of people to put in front of a college algebra class, That's what we hear from some of the rural schools. In fact, when we started talking between the 2 years and the 4 years, one of the things that was surprising to us was that some of us at 4 years that have a lot of students not being funneled into college algebra had no idea that all the community colleges were putting them into college algebra, and vice versa. The community colleges had never had that conversation with their 4 years, even the ones they have close relationships with.
Great, go ahead, Amy.
So I worked closely with Colorado, and I wanted to mention a point that this actually comes up in a lot of sites, is when we ask why is quantitative reasoning not used more as a pathway, this falls into that category of math for liberal arts, which unfortunately math faculty have sort of used as, this is the favorite topic I want to go teach, so this is the chance I get to do that. And it's been focused on things like, math appreciation, which, I mean, I want people to appreciate math too, but I think they'll appreciate it more if they can use it. So one of the things that is kind of a hard discussion to have with math faculty is if we want programs of study to consistently accept quantitative reasoning courses for their programs, then we have to provide some consistency about what's in those courses. And that came up in Colorado because there is a little bit of this, but we like that flexibility. So that's just something that I think people need to be prepared for, but it's a really important conversation to have.
So that actually makes a really important point, because I think one of the responses we've heard, and I'm sure you have heard, is that you're talking about dumbing down the curriculum here, or that you're thinking about creating lower standards for students by creating these other courses. When in fact, what you're saying, and I think is unfolding in some of your states, is indeed, no, we're talking about creating rigorous pathways and taking some of these courses that maybe have been withering on the vine and beefing them up a bit, right? I mean, is that sort of how the conversation's unfolding in your states? Anybody want to jump in on that?
Sure, that's been an explicit part of our conversation.
Right.
Sure.
And that's sort of the power of having faculty being the ones that are defining this conversation, right? So that's, I think, very exciting. So Mary, I want to turn to you a bit. So you had a little bit, I mean, I think very similar situation, but also some unique elements to it in terms of some of the particular challenges policy-wise that you're up against in Missouri. So maybe you could tell a little bit about how your challenges sort of translated into the need for pathways there in Missouri.
All right, yes, thank you, Bruce. We had a math summit before we joined in this group. About maybe 2 weeks before that, we had a math summit, and one of the issues that came up at that was that we have a policy posted on website by the, and I always confuse which one of these is which, Missouri Department of Higher Education, that says that any course any math course that is going to be accepted for college level credit must have intermediate algebra as a prerequisite, or must have the same prerequisite as college algebra, is how it's stated, which is intermediate algebra. So that caused what you might say, we can't do anything, we have to get everybody through intermediate algebra before we can let them take a college level math course. So we were confounding the idea of a pathway with the remediation that needed to go on. And then as we got to talking further, unbeknownst to some of us who are not part of our flagship institution, University of Missouri requires that every student take college algebra, regardless of major. And don't seem to be very flexible on that, although we are making some discussions. They have a new provost and everything. So we met with two problems. We had the flagship institution required college algebra, therefore every community college advising student wanted to go to the University of Missouri, therefore they were forcing or advising their students to take college algebra because it was a guaranteed transfer. And then if at other institutions like mine and most of the other ones around the state, if you had alternate pathways, a stats course or a liberal arts course, it had to meet the intermediate algebra prerequisite. not because algebra was what was needed in those courses, but because there was this feeling that there was a maturity that was gained when students had an intermediate algebra background. Well, most of us know that those two things don't go together, but that was the policy that was there at the time and is still there, and that's one of our big recommendations.
So it's not just about college algebra, it's about this intermediate algebra question.
Things.
So of course, one of your key recommendations is to get rid of that requirement. And what do you think that presents in terms of an opportunity now, in terms of what Missouri is going to be able to do if indeed you can get that policy changed?
I don't think there's a problem getting the policy changed. It's just a case of actually all the people in charge of the policy are willing, they just want to get the wording right on it. But what it will do is it will open up courses, say a tech math course, because you don't need the intermediate algebra to do the geometry that's required in much of the technical math that would be needed for automotive or welders or things like that, that many of the community colleges, or several of them, are very interested in. There's an architecture course at one of the community colleges that, because those students don't transfer on, they do have a course that opens that up for actually the creation of pathways that where the remediation, the co-requisite model, will actually fit with the course that's being developed.
So you're sort of unleashing
Yes.
the possibilities because of that one small policy change.
One small change.
So you had a similar challenge in Ohio, right, where you had this intermediate algebra requirement. So talk a little bit about the change you've made there and sort of how that's now taking shape, keeping in mind that Ohio's a little bit further down the road. So you've got a pretty clear sense of where you're going now based on just that set of recommendations you did a year ago. So talk about it, Rebecca.
Sure. So this is work that is absolutely led by faculty, and the faculty leadership group, we have folks with us here, they sat down and they looked at what were in the articulation and transfer network requirements in place for all Gateway mathematics courses, and the recognition that intermediate algebra should not be a prerequisite for all Gateway courses. And in fact, there was the discovery that there was some inconsistency, in fact, across the state in how intermediate algebra was being used, and being used in some instances actually as a college credit-bearing course, so even discovering kind of more discrepancies around the state, and a coming together and an endorsement from faculty statewide that, in fact, we should not have intermediate algebra as a prerequisite for all college credit-bearing transfer guaranteed mathematics courses across the state. This went out for statewide endorsement, was strongly supported. We have a very strong chairs network, and that work is being supported by that chairs network. And in fact, that policy change was made, and I think it's important that faculty are making this policy change, because that's the articulation and transfer guarantee across the state, is this peer review of the courses, and it's a faculty-led work that is academic in nature, but is also keeping student success at the forefront.
Great. Go ahead, Amy.
Bruce, I just wanted to make a point that if you're considering work like this, when we first started the work with this, the CCA group, we got a few questions of like, well, Ohio and Georgia already published these really nice reports. Can't we just take their recommendations and adopt them? And I think you just heard that each one of these groups discovered something in the process that was unique to their state and that they needed to address. And that is so important. So I really encourage people not to look for shortcuts and take the time for a process where they really dig into data, they come together and understand and find some common understanding about what's going on in the state.
So let's just get to brass tacks, Dean, because you guys just came up with, I think, a pretty clear articulation of what your math faculty think an appropriate set of pathways might look like. Could you just take a minute and describe, sort of what you've developed and how you've designed that and what you're proposing?
Sure. Well, we're recommending that 3 pretty distinct pathways be designed. We've coined them without too much originality: a calc path, stat path, and a quant thinking path. I should say that we certainly recognize that there are some unique populations that don't fit neatly into these 3 categories. At my institution, we have a very, very large elementary ed population, for example, and we have a nice set of 3 math courses that all pre-service elementary students take. But having said that, the calc path is pretty self-explanatory. The main piece of our recommendation related to the calc path is that we want to make sure that we all know that it's vitally important for anybody on a calc path to complete Calculus 1 within their first 30 hours of study if they're really going to move on and get a science or a math degree in a timely fashion. So we're recommending that institutions provide co-requisite support either in pre-calc or calculus in order to achieve that goal. Of course, we would all love it if all of our students came calculus ready, but we know that's not the reality. The STAT path, we have a pretty well-defined introductory stats course that's common among all the community colleges. We think that serves as a good model, should be adopted across all the 4 years. In particular, that does not have the credit-bearing college level algebra prerequisite, because some of our 4 years have even as much as college algebra as a prerequisite for their introductory stats. We're recommending that be changed. And then this third path, the quant thinking path, we're not thinking of that as a particular course. We're thinking of it as it would be a set of courses. We're acknowledging that institutions have some differences in their the students they serve. This would be the course, however, that would be for students that need a good foundation in college-level mathematics, but are not headed in a stat path, not headed on the calc path. It might be one of the revised math for liberal arts, making some of the changes that Amy referred to a few minutes ago, where some of the problems that we've identified with that course is sometimes there's a lot of just appreciation of math topics that we don't think are make the course as rigorous as it might be. It also, some people tend to have that be a very broad course. It's like almost a topic a week or a topic every 2 weeks. So we'd like to see some consistency across the state. Have that course, everybody would have a focus on financial literacy, on descriptive statistics, and then on developing numerical and reasoning skills for their students. Another course in this quant thinking path that many faculty are interested in working on would be an algebraic modeling course, but it would be one that would not have an intermediate algebra prereq. So this would be a course for people in majors that need some algebra skills, certainly nothing on the level of people heading into a calc path, but would also be able to provide the kind of problem solving and development of quantitative reasoning skills that we want to have happen in this quant thinking path, but would have more algebra content than the first course I described. So that's kind of where we're coming down.
So, I mean, I think this really suggests, right, is that it's really about a better communication and articulation for students and advisors to understand what their options are, right? And I think that's something that I didn't come into this fully appreciating. So I know in all of your states, Rebecca, maybe you can comment on this, the importance of advising and how the impact this trickles into that work and that world. So can you tell me a little bit about how you're seeing that there in Ohio?
Sure. So we had a Student Success Summit just a few weeks ago, and one of the most important groups that we wanted to invite were the advisors. And we looked at this also as a P16 piece. So we invited high school counselors as well as college advisors, because having pathways in place, having gateway courses that are truly gateway courses that will serve the needs of all majors regardless of their career goals is fine, but if students are not being advised into the appropriate gateway courses or the appropriate pathways for their own specific desires, then all of the work of the faculty is for naught. So It's really important to get the advising faculty, the advising professional advisors that are, because there's a different advising model at every institution, getting all of the folks that are engaged in advising and backing that down to the high school level so that we're making sure that as we advise students, it's in their own best interest so that they are strengthened in the specific skills and knowledge that they need for success down the line. Now, the big challenge for us is we're building this at the same time we're trying to build this communication with the advisors, and so that work, that connectivity, and that constant engagement with advisors is going to need to continue for the foreseeable future because we are building the plane while we're flying it. So there's a lot of that engagement work that has to be there, but to your point, we have to be sure that we're keeping the folks in the advising chair for each of those students. We need to keep them very well engaged.
Right. Go ahead, Dean.
So another really important piece that we've identified has been needing to have better coordination between the math department and our partner disciplines. Because some of what's driving, say, the college algebra as a default in Colorado, we think it comes down to faculty in some disciplines at some perhaps flagship university. I'll pick on anthropology. Probably not too many people from anthropology here. You know, you may have some faculty who have said, we think college algebra should be the required course for anthropologists. I took it. It's a good, you know, frankly, it weeds out students. We make sure the students that get into our major, you know, this is a hypothetical, but it's not too far off from reality. Certainly when you start to have these conversations with the faculty in these partner disciplines, and you say, well, what do you want your students to, what do they need for their future studies or for their future careers? Very few things they learned in college algebra are going to show up on that list. So part of our recommendations are going to be trying to get processes in place to really get those conversations to happen between math departments and the partner disciplines.
So Mary, did you want to comment on that? I mean, we talked about sort of that as sort of a next set of work, right? Once you sort of blow the lid off intermediate algebra and you start talking about what students really need, that conversation with the disciplines becomes really another key piece. So talk about sort of how you're thinking about that there in Missouri.
And as we start thinking about it, as of about a week ago, is today Wednesday or not? Okay. Wednesday last week, I met with our Dean's Council at my institution, and they said, yes, we'd love to work with you, discipline specific, but you need to give us a list of the math competencies that are possible. Because their version would be, as Dean said, well, I had college algebra, it worked for me, or I had calculus, it worked for me. And then you go through what their students need, and they need, instead of that, they need to understand some major stuff about geometry or three-dimensional space, but not the stuff that you would get in a Calc 3 class, because they didn't go that far. So creating and I hate to say, not a set of topics, but a set of competencies that you can go to faculty with and have engaged discussions that are supported at the highest level. I talked with Amy about this through email, that the provost, your deans, those people at each institution have to be engaged with this and encouraging all the faculty to participate, not just one person in this department and one person in this department. But the takeaway would be trying to get a good list of competencies that you can take and use with very heartfelt discussions, either in focus groups or our chairs asked for it, said, give us this list this summer so my faculty can work on it while they have time. So, because when school starts, they're not going to have time, they're just going to sit down and check off the list, well, this is what I had in my class, this is what I need. And then the second part is ask them for specific examples. Okay, why do you need, this is my favorite word, why do you need to, we'll pick anthropology, simplify a rational expression? Okay, where is that going to come up in what your work is? Why would we need that in the college algebra curriculum? Why do we need that specific? What is that we need? Is it because they need to go into calculus, and then maybe there is a reason they need it? But is it because all they're going to see there is they need to be able to recognize patterns, look at symmetry? So where did the rational expressions come in this? No, it's just because I had that in school. So, but that list of competencies and the high-level support to go and talk to everybody within the faculty, everybody.
So once again, I mean, it speaks to that quality argument again, that we're talking about really taking a good hard look about what students really need to be successful in mathematics. And I think that's really, in addition to the clarity it creates for students into programs of study and to be successful, is really the big win here. And it's great to have the faculty leadership. I want to pause. I know that we're throwing a lot at you here. Is there any questions that people have at this point? Go ahead.
So in Connecticut, we've already done a lot of this. However, I'm really interested in, my voice is pretty loud, but, okay, so in Connecticut, we've already done a lot of this. But what I'm really interested in, we've articulated to the four-year institutions from the community colleges, they will take our liberal arts that only requires intermediate algebra, and they will accept our statistics that only requires intermediate algebra. But what I'm more interested now is, are we talking about a pathway that is a liberal arts class, math for liberal arts, that doesn't require intermediate algebra? And what about stats? We're talking about stats that doesn't, because we have Statway. So I know what Statway is. We've had Statway, but is there a true principles of statistics, you know, beginning, because you really, the secret is you don't need intermediate algebra to do statistics. But yeah, but you know, that's a secret. Yeah, that's a secret. But I mean, you know, they all, but our articulation with the 4 years, we have it now so that we've lowered it to intermediate algebra, but now y'all have articulated it so that they'll take a stats and the math for liberal arts without intermediate algebra. Okay, that's cool.
So I would like to note that the American Mathematical Association of Two-Year Colleges a year ago, maybe 2 years ago, put out a position statement that said intermediate algebra should only be used as a prerequisite for algebra-based courses. That's not statistics. And there are many leaders in statistics that are saying, no, you do not need intermediate algebra. And actually, the Dana Center is going to have a position paper coming out on this soon. As soon as I get it done.
Question here.
How have your boards of regents been supportive or created barriers for these efforts?
Rebecca, you're at the Board of Regents.
So I'll speak to this first since I'm with the Board of Regents. The Board of Regents has been dedicated to supporting faculty as they do this work. It's about student success. It's about completion. The emphasis is not on admissions and enrollment any longer. The emphasis is on when you bring in students into your institutions, seeing them through to success and completion. And this is a way to do that. This is a way to move from what we call them gateway courses, but they've really been barriers to many students. So they're really gates, not gateways. And so the Board of Regents is grateful to our faculty for doing this work and highly supportive of that. And it's partly, again, I spoke to it earlier, but it's because the faculty are leading this work that we know the academic rigor is there. We know it's robust. We know that they are looking at this through that lens, but also thinking about what makes the most sense for students. So at least in Ohio, we applaud and support and do everything we can to help with the faculty effort in this realm.
So we do have to wrap this up. There is a breakout session this afternoon for all these folks, so if you have more questions, that's going to be an opportunity for you to get that greater level of depth. But what I want to do to close this out is have each person sort of say, what's one takeaway that you want to communicate to folks about, if you're going to do this work, something that you need to keep in mind or that you're excited about? Start with Mary.
My one takeaway is, even if you work in a state where you have an institution or two putting up barriers, don't let that stop your work. You can do a lot with everybody. We have all 26 institutions in the state involved, and you can do a lot, even if one is sort of dragging their feet.
All right. Dean.
It's a point that's been made many times today, but we want to get some data. It really is convincing when you start looking at your own state and local institutional data.
The silos have to come down, and they are coming down, so that whether you're mathematics faculty or English faculty or social sciences faculty, you think of yourself beyond your own discipline, and you think of yourself as general education faculty as well, and you're having those conversations between disciplines so that regardless of the student pathway, you're serving a utility as a general education faculty member as well as your specific discipline, for example, for STEM majors.
Amy.
Don't let the challenges get too much in the way early on. Things like advising come up often really early, but you can say, yes, we can deal with that. It's going to take some time, and keep the student in the center of the conversation at all times.